Hello, good evening guys. Welcome to BYJU'S exam prep. Very good evening all of you. I hope everyone is fine, good. So today in this session, we will be discussing 5 very important questions from the topic of vibration. And by solving these 5 questions, almost your 80 to 90% of vibration will be covered. So that is the reason this is very important for all the GATE aspirants, those who are planning to give GATE exam in the year 2024. So good evening, good evening. I hope everyone is good. Yes. Please do share this video to all of your friends so that they could also join and they will be able to understand the concept behind the vibration. I'll be taking some questions from the natural vibration. I'll be taking some questions from the force vibration also and from the damped vibration, right? Okay. So very good evening all of you. All good, all perfect. Let me check from my end also. Yes, all good, all perfect. Okay. So, shall we begin? All perfect, right? Okay. So, let me introduce about myself. I hope everyone has connected with me on my Telegram channel also, and you can drop me a message on my mail that is sudas.s9@byju's.com. Hello, Arnab. Good evening. Good evening. Please do share this video so that all of your friends will be joining. And I told you this is important for GATE examination because we'll be taking questions from natural vibration, from the damped vibration and the forced vibration. We'll be taking the collection of all the 3 topics in 5 questions. That means if you are solving these 5 questions, your entire vibration topic will be covered. Okay, fine. Chalo. So before starting the session, let me first of all tell you about some important update from our side. As you know that on 25th of June at 9 a.m. our scholarship test will be conducted. So make sure everyone is registering yourself to this scholarship test after this session, not right now. You can log into our app, and also it is there in the description box also, right? The link. And also Richa ma'am will be coming up live on 27th of June at 7:30 exactly. Please be on time and register yourself to this very interactive workshop where she will be telling us about the strategy to be in the top 1% in GATE 2024. Okay, fine. The description is in the comments. The link is in the description box. Please try to register yourself. So, shall we begin? Okay. So, first question from the concept of natural vibration. A uniform thin disc of mass 1 kg and radius of 0.1 meter is kept on a surface as shown in the figure, connected by 2 springs K1 and K2. Right, both definitely having the different stiffness. Initially, both springs are unstretched. Now, it's very important that assume pure rolling of the disc. For small disturbance from the equilibrium, the natural frequency of the vibration of the system will be. Try this problem right now in the live session and we'll be discussing the concept behind this. Now, here, whenever you are getting any question from natural vibration, try to apply 2 very important methods. Okay, first one is a torque method. Like majority of the questions will be tackled out with the torque method. If torque method is not you're feeling difficult in torque method, then you can apply the energy method, right? Okay, and Rayleigh method will only be applied if you're having only one static mass where we can calculate the static deflection. The best will be a cantilever beam, right, or simply supported beam, because you know what is a static deflection at the different points. You have studied in your strength of material, right? So Rayleigh method is quite helpful in that kind of situation. But now in this case, as there are 2 springs connected, so let us try to apply the concept of torque method. Okay, now let us assume that if I say if this roller is making, this particular disc is making a pure rolling motion, can you tell me where will be the eye center located? Anyone? If there is a disc which is making a pure rolling motion, can we say its eye center will be located exactly at the point of contact, at point O, right? Now, let us suppose I am making a slight deflection in the clockwise direction. Okay, I'm making a slight deflection like this. I'm making a slight deflection in the clockwise direction where theta is the slight deflection, small disturbance. Now, tell me one thing. By making a small disturbance, this B point will be shifting to right hand side. So the spring will be compressed, right? The K2 spring will be compressed. So can you tell me what will be the deflection in spring K2? Please write in the comment section. What will be the deflection in the spring K2? Anyone? Now total distance from O to B is 2r, that is a diameter. If I'm making a r, so that length or distance will be 2r theta. Can we say the deflection being made will be 2r theta? Yes. The deflection in the spring K2 will be 2r theta. And what will be the elongation in the spring K1? This is connected at the center. Can we say will be having r theta will be the deflection in K1. So what will be the spring force? Now K2 spring is being compressed. It will try to apply a force in this direction, right? K1 spring is being expanded. So it will try to make itself come back to its mean position. So it will try to apply a force in this direction. And what will the force? K into deflection. So K2 into 2r theta will be the spring force acting in spring K2 spring, and K1 r theta will be the spring force acting at the K1 spring. Okay, fine. Is this clear till this point? Now we are applying the torque method. Right? Now in torque method, what we do, we try to calculate the torque at different points, right? Okay, now if I talk about this K1 r theta force, it will try to make this body come back to its original position. That means that it's a restoring torque. It is against the direction in which we have provided the motion. If I'm making a clockwise small disturbance, if I'm making, right, so this body will try to come back to its mean position, and the torque response will be K1 r theta into r. Yes, force into distance from 0 to a, what is the distance? That is r. If I talk about K2, there also will be having a restoring torque of K2 2r theta into 2r. That's it. There is no other force which will be responsible to make this body to come back to its original position, right? So I can say 0 minus K1 into r square theta minus K2 into 4r square theta is equal to I naught into theta. This is basically D'Alombard's principle. Now, if I'm having a disk, right, if I'm having a disk, okay, and if I want to calculate what is the moment of inertia about point O, this is a solid disk. It's given that it's a thin disk, right? So it's a solid disk. So moment of inertia about the center of gravity will be mr square by 2. So what will be the moment of inertia about point O? That will be equal to mr square by 2 plus mr square. That will be equal to 3mr square by 2. 3mr square by 2. So placing all these equations in this standard formulation, so I naught theta double dot plus K1 r square theta plus 4k2 r square theta equal to 0. Okay, fine. Placing the value of I naught, will be having 3mr square by 2 theta double dot plus K1 r square plus 4k2 r square into theta equal to 0. Now r square will be cancelled out. So we can rewrite this equation as, theta double dot plus K1 plus 4k2 divided by 3m into 2 into theta equal to 0. Okay. So we have calculated the standard formulation, and we know what is the generalized equation, that is equal to theta double dot plus omega n square theta equal to 0. Comparing these two equations, we can say omega n square is equal to 2 into k1 plus 4k2 divided by 3m. Okay, fine. So omega n is equal to root of 2 into k1 plus 4k2 divided by 3m. This is the final answer, 23.1, right? So let us place the values, right? So it is 2 into k1 value is, what is the value of k1? That is 400 and k2 is 100. Okay, so this is 400 plus 400 divided by 3 into, what's the mass we are having? Mass is 1 kg. Mass is 1 kg, root of this. So this is 2 into 800 by 3. Okay, so this is 40 by root 3. 40 by root 3. Okay, fine. Is this clear? So what is the value you're getting? Somewhere around 23. We'll be getting somewhere around 23.1 radian per second. Is this clear? Fine. 23.1 radian per second, the first correct answer that we have got. Now, very important information that you have to understand is, whenever you are dealing with these kind of questions, always remember that torque method is one of the most helpful, most frequently used method for solving the questions in natural vibration, and it is quite easy, right? Only thing you have to do is you have to identify what is the number of torque, restoring torque that is being applied on the body, which will try to make the body to come back to its mean position. Identify the number of torque, okay, the restoring torque, and that should be equal to the inertia torque, that is I into alpha, I theta double dot. That's it. Okay, fine. Now let's go with the second problem on the screen. A slender uniform rigid bar of mass m is hinged at point O. So we are having a point O at which this particular rod is being hinged. We are having two springs having a stiffness of 3K and K, and a damper is connected having a damping coefficient C. For the system to be critically damped, what is the damping factor for critically damped? It's being clearly stated that this is a critically damped system. That means your zeta will be equal to 1. Okay, your zeta will be equal to 1. So you have to calculate what is the ratio of C divided by root of Km. What will be the ratio of C divided by root Km? So let us try this problem. Now again, there's a rod. Okay, so if we try to give slight deflection, so again we have to apply the concept of torque method. Okay, fine, 1. Okay, let us see, are we getting 1 or different value? Okay, so let me give you, let us suppose I'm giving some initial deflection like this. This is the initial deflection that I'm giving. Let's say this is theta. If this is theta, this is also theta, right? Now tell me one thing, what will be the deflection in the spring 3K? Write in the comment section what will be the deflection in the spring 3K quickly. If this is theta, from the hinge point to one of the end, the distance is L by 4. It will be nothing but L by 4. This will be L by 4. This will be L by 4 sine theta. Now theta is very small, so sine theta will be tending to theta. Can we say this will be equal to L by 4 theta will be the deflection in the spring 3K, right? Okay, fine. And the 3K spring is being compressed. That means the force acting on this particular body or this particular spring will be in the downward direction, right? Or I can say the restoring torque will be in this direction. Exactly. Very good. Very good, right? Okay. This is the only I'm writing the deflection. So if I want to write what is the torque, so this is 3K into L by 4 theta into L by 4. Hello Raja. Good evening. Good evening. Now talking about this one spring. Now this spring, what is the distance from this end? This is equal to 3L by 4. So the deflection in this spring will be 3L by 4, 3L by 4 into theta. The force will be K into deflection, that is K into 3L by 4 theta, right? So now the K spring is being elongated, so it will try to apply a torque in this direction. So what will be the magnitude of this particular torque? This is K into 3L by 4 theta into L by 4. So this is the restoring torque at the spring having stiffness K. Right? Now we are having a damper also. We are having a damper also. Now what is damping force? Anyone? Good evening, good evening. What is damping force? That is C into the coefficient of damping into the velocity. Right? C into x dot is the velocity. But can you tell me, if there is a deflection happening of theta, what is the deflection at C? So this is L by 4. So this will also be L by 4 because C is exactly connected at the center point. C is exactly connected at the center point. Okay, fine. So the deflection over here will be L by 4, but we need to calculate x dot. So if deflection L by 4 theta, so if the deflection is L by 4 theta, if you try to differentiate this with respect to time, this will be theta your dot. So this will be equal to, okay, this is your displacement, rate of change of displacement is velocity. So velocity will be equal to your L by 4 into theta dot. Okay, so here we'll be having L by 4 into theta dot. This is the force acting into L by 4. This will be the torque, and this will be acting in the restoring torque will be equal to C into velocity, that is L by 4 theta dot into L by 4. So we have calculated all the restoring torques. Once we have calculated all the restoring torques, next step is add all this, right, and write in the D'Albert's principle, that is 0 minus restoring torque is equal to I0 into alpha. So 0 minus, what is the restoring torque? We are having the 3K, it is 3K into L square by 16 theta. This one will be 3K, this will be equal to K into 3K L square theta, 3K L square theta. This will be L by 3L by 4, 3L by 4. Okay, the distance is 3L by 4. So this is 9K L square by 16. What is the damping force? This is the damping force that we are having, that is minus of L square by 16, L square by 16 into C into theta dot is equal to. Now, can you tell me, if we are having a rod, right, and we are having a hinge point at a distance of L by 4 or L by 4 from the center, right? So what will be the moment of inertia I naught? Can you tell me? What will be the mass moment of inertia of a rod at a distance of L by 4 from its centroid or center of gravity or centroidal axis? So we know that centroidal axis moment of inertia is ml square by 12. So I naught will be equal to ml square by 12 plus m into distance square, that is L by 4 whole square. So I can say I naught will be equal to, we can write it over here, I naught will be equal to ml square by 12 plus this is ml square by 16. Okay, so this is 28 ml square by 12 into 16, right? So this will be equal to, this will be your 14, 6, 2, 3, 7. So this will be 7 by 48 ml square. 7 by 48. Very good evening Prem Saga. 7 by 48 ml square, right? So we can place it over here, 7 by 48 ml square into theta double dot. Okay, fine. So rearranging the equation, we can say 7 by 48 ml square theta double dot plus L square by 16 is all same. Okay, it's not capital or small, it is all same. L square by 16, it is L square by 16 C theta dot plus, now adding this 3 plus 9 is 12, so 12 by 16 K L square theta equal to 0. L square will be cancelling out, L square will be cancelling out, 16 we can take it as common, so this is 7 by 3 m theta double dot plus this will be C theta dot plus 12k theta equal to 0. So from here I can say theta double dot plus 3 by 7, this will be C by m theta dot plus this will be 36 by 7 k by m theta equal to 0. So we have calculated the general expression of the this one damped vibration. Okay, we have calculated the general this one. Now we compare with the standard formulation. What is the standard formulation? Theta double dot plus 2 zeta omega n into theta dot plus omega n square theta equal to 0. So comparing these two equations, we can find out very n number of values, right? And the best part is they are saying that it's a critically damped, so zeta is by default equal to 1. They are saying what will the ratio of C by root Km. Okay, so comparing these two, we can say omega n square is equal to 36 by 7 K by M. So omega n is equal to 6 by root 7 under root of K by M. Okay, we have calculated the value of omega 1. Now this equation will be comparing with this. So 2 zeta omega n is equal to 3 by 7 C by M. Now zeta is already equal to 1 because this is a critically damped system, and omega n value we know. So this is 2 into 1 into 6 by root 7 K by M, root of this is 3 by 7 C by M. Okay, rearranging this equation, this will be 3, this will be 2, 4. So we'll be having 4 by root 7 into 7 equal to C by root K into M. C by root K into M. So I can say C by root K into M is equal to 7, this will be 7, that will be 4 root 7. Okay, 4 root 7 will be the correct answer. Right, so what's the nearest value that we are having? Option A, B, C or D? Acha, we are getting 4 root 7 directly. Option D, 4 root 7. Is this clear? Question is very easy. Only thing you have to go for step by step, and always remember that vibration in entire theory of machine, vibration is the only topic, specifically the natural vibration is the topic where you have to practice lot many questions. Okay, where you have to practice lot many questions. So here we are getting the final answer as 4 root 7 as the final correct answer. Okay, fine. Option D, 4 root 7 is the final correct answer. Clear hai? Understood? Can we go for the third question? This is only the second problem that we have discussed. Let us proceed. The third question, which is mostly asked in the GATE also and ESE, that is from the damped vibration. Majority of the time you are getting a question like this. Now let's read the question. Consider single degree of freedom system comprising of a mass M. This is your mass M. Okay, this is the mass M that we are having, right, supported on a spring and a dashboard. If the amplitude of the free vibration response reduces from 8 mm to 1.5 mm in 3 cycles, that means we are moving from x0 to x3, that means from 8 to 1.5 mm. What is the value of the damping ratio, that is zeta? Many number of time you might have seen this kind of question in GATE also, in ESE also, and in different PSU examination. Okay, so let us try this. Now we know that as a simple concept under the damped vibration. Okay, if I talk about the under damped vibration, let us have a quick recap of the concept. If I talk about the under damped vibration, under damped vibration means, or under damped system means, your zeta is less than 1. Now what is the graph between the amplitude versus your time? So it always follows a exponentially decreasing amplitude curve like this. This is the amplitude of vibration. That means after some point of time your vibration will be tending to 0. This is your time. It is not going on till infinity. This is your x. Okay, amplitude x. Okay, fine. So it is decreasing in an exponential way, and it is being seen that the consecutive ratio, let's say this is x0, this is x1, the consecutive ratios of the amplitude, it is always having an equal ratio. It is always have the equal ratio, and that is equal to e to the power delta. E to the power delta, where delta is your logarithmic decrement ratio. Logarithmic decrement ratio. Is this clear? Okay, fine. Logarithmic decrement ratio, right? So let us try to understand and apply the concept over here. Now x0 by x3, we can write this x0 by x3 as x0 by x1 into x1 by x2 into x2 by x3, that is 8 by 15 into 10. Now x0 by x1, x1 by x2, x2 by x3, they all are having the same ratio, that is e to the power delta. So I can say this is e to the power 3 delta is equal to, this is your 80 divided by 15, or we can say taking logarithmic on both the side, delta is equal to 1 by 3 ln of 80 divided by 15. Can you tell me what's the value of logarithmic decrement? Anyone? Those who are calculated, please do let me know what is the value you are having. The delta value 1 by 3 log of this one. Yes, I need answers from your side also. Quickly. Kitna hai value? 1/3. 0.56. Perfect. I was getting 0.558. You can round off to 0.56. One important suggestion from my side is, whenever you are solving a question in GATE examination, try to take up to 3 decimal. ठीक है, उसके बाद no problem. 4 decimal तक की जरूरत नहीं है, 2 थोड़ा कम पड़ेगा. So try to take up to 3 decimals. Okay, that is self-sufficient. Now we have calculated the value of the logarithmic decrement. So we need to calculate, is there any relation between logarithmic decrement and the damping factor? Yes, we do have a very interesting relation. That is, delta is equal to 2 pi zeta divided by under root of 1 minus zeta square. Okay, so delta we have calculated. We need to calculate the value of zeta. But if you try to place it over, it becomes slightly complicated, right? So let us do one thing. Let us try to rearrange the this one, the your parameters, and let's calculate the value of zeta. So I can say delta square is equal to 4 pi square zeta square divided by 1 minus zeta square. Okay, so again rearranging, we'll be having your this one will be zeta square is equal to delta square divided by 4 pi square plus delta square, something like this. Okay, we are getting something like this. So zeta is equal to delta divided by 4 pi square plus delta square root of this. So now we got the value of zeta in terms of delta. Place it and tell me what is the final correct answer. Let's see. Prem Sagar, Raja, Arnab, quickly all of you try to place the value of delta and tell me what is the answer. 0.558 divided by 4 pi square plus 0.558 whole square root of this. So that will be the value of zeta. Definitely it should be less than 1 only, because we are talking about the underdamped system. Very good. 0.088. 0.088, and let's see what they are asking. They're saying that round off to 3 decimal. In the question also they have told to round off to 3 decimal. So 0.088 is the final correct answer. 0.088 is the final correct answer. Okay, done everyone? Because this question majority number of time is being asked in ESC prelims. Okay, they'll be asking till this point. In ESC plane, they'll be asking till delta value. In GATE examination, they'll be asking till zeta value, because calculator difference aa jata hai. In GATE, calculator is allowed, so definitely you can solve till this point. In prelims, we are not having calculators being allowed, so they are asking till the delta value. Okay, fine. Is this clear? Can we go with the fourth question on the screen? 3 questions done. Fourth question. Okay, so fourth question, one of my favorite and also a concept from the forced vibration. Forced vibration से ये question है. Let's read out what's the question all about. A machine of mass 100 kg is subjected to an external harmonic force with a frequency of 40 radian per second. So they are saying that the external frequency is 40 radian per second. That is machine frequency. The designer decides to mount the machine on an isolator to reduce the force transmitted to the foundation. Okay, so we are applying a vibration isolation in order to reduce the amplitude of vibration. Okay, the isolator can be considered as a combination of stiffness and damper. That means there is damper is present. It's not like the zeta is equal to 0. So damper, combination of damper and spring is there in parallel. So designer has 4 different combination. You have to tell me, arrange the isolator in the ascending order of the force transmitted to the foundation. That means you have to go from lowest to the highest. Okay, that means we have to say zeta ka increasing order pe we have to arrange. Not zeta, it is E. Transmissibility ratio ke increasing order pe we have to proceed. Right? Okay, now In this question, majority of the students, what they do, they calculate the amplitude or zeta value. They calculate the zeta value for the four different cases. We should not be doing like this. We are having a formulation that the transmissibility ratio, that is Ft by Fo, right, that is equal to 1 plus 2 zeta omega by omega n whole square under root of this divided by 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square under root of this. Now, if you try to calculate, they have given the value of k, you can get the value of omega and also what is the value of omega n? Omega is the under root of k by m, mass is given, k value is given, you can calculate very easily, right? But if you apply this formula 4 different times, A, B, C, D, it will surely gonna take minimum of 5 to 10 minutes, minimum. I'm not saying that maximum of 10 minutes, but minimum, I personally will be taking 7 to 8 minutes to solve individually one by one. It's a very big formulation. Okay. So what we have to do, let's try to apply a slightly different approach in order to solve this question. Now, if you look at this options, there are two combination of spring. Like if I say, are you able to see this? A and B. Let me hide myself. So there are two combination of spring. This is having the same stiffness. I'm only taking the K value, and these two are having the same stiffness. Okay, fine. So let us do one thing. Let us take the first combination. Let us take the first combination when your K is equal to 640 kilonewton per meter. Okay, 640 kilonewton per meter, and we know the value of mass. Mass is equal to 100 kg. Let us first of all calculate for this spring combination what will be the value of natural frequency of vibration, that is under root of k by m. Can you tell me the answer? The value of omega n. This is 640 into 10 to the power 3 divided by 100 root of this. So this will be 1 to 2. This is 6400, that is 80. Yes. Are we getting 80 radian per second? 80 radian per second. That means for these two combination, omega n is equal to 80 radian per second. 80 radian per second. Now let us talk about the second combination when k is equal to 22.5 kilonewton per meter. Mass is 100 kg, right? Calculate the value of omega n over here. Omega n is equal to under root of k by m, right? So this is equal to 22.5 into 10 to the power 3 divided by 100 root of this. So this is root of 225, that is 15 radian per second. Are we getting 15? Root of 225, 15. So for this combination, omega n is equal to 15 radian per second. Now let us calculate the value of omega by omega n. Omega by omega n. Omega is 40. So 40 by 80, that is 0.5. 1 by 2 is 0.5. And for this two combination, omega by omega is equal to 40 by 15, that is somewhere around 2 point something. Kitna hai? What is the value of this? This will be 8 by 3, 2.67. 2.67. Okay. Fine. So now we have identified that omega by omega n value, and we are having the zeta value changing from 0.7 to 0.07. There are two different combination of zeta. So now let us do one thing. To answer to this problem, let us draw the graph. Let us draw the graph, and by using that graph, we'll be able to answer to this problem very easily. Right? This is omega by omega n on the x-axis. This is transmissibility ratio on the y-axis. This is value equal to 1. Okay. Let's say this is resonance, that is 1. This is root 2. Right? Let me draw it like this. Okay. Now, let us try to plot this curve. Let us try to draw this curve, and let us try to identify what is the value we are getting. So if I talk about this particular undamped system, if there is no damping, at resonance will be going on till infinity, and it will be going on like this, passing through root 2. Okay, this is your zeta equal to 0. I'm just only showing, right? So next value is we need to calculate for which one? There are two possibility, 0.7 and 0.07. So let us say this is 0.7. This blue line indicates zeta is equal to 0.07, right? And your green line, if I'm having a green line already we have taken, so let us take one more color, dark green. So that second is 0.7. So 0.7 will be here, will be having a lower value, right? So here will be, let me do one thing. We take a white color, because that will be very much easy to distinguish. So we are having a curve like this. This is zeta is equal to 0.7. Okay, zeta is equal to 0.7. So we have plotted the curve. This is omega by omega n. Now we know that when omega by omega n is less than √2, less damping, more E. If omega by omega is greater than √2, less damping, less E. Okay, that is the trend of this curve. Now, we are having four possibilities. The first possibility is omega by omega n is 0.5. For the first case, omega by omega n is 0.5. That way, it is less than √2. It is less than √2. Somewhere around here, let us say this is 0.5. Okay, fine. So, first possibility is A is having 0.7. So, 0.7 curve is white one. So, this is 0.7. Okay, this is your zeta is equal to 0.7. This is, let us say, A. Second possibility is B is having 0.07. This is B, right? Third possibility is your omega by omega n is 2.67. So it will be definitely greater than that of √2. So let's say this is 2.67. Okay. So here the first is zeta is 0.7. Zeta equal to 0.7. This is the point. It will be somewhere around here, that is C. And the last one is when zeta is equal to 0.07. This is 0.07, somewhere around here. Okay, so we need to write in the increasing order. That means lowest first. Lowest is D, then we are having C, then we are having A, then we are having B. Okay, fine. We are having 4, 3, 1, 2. 4, 3, 1, 2 as a final correct answer. 4, 3, 1, 2 as a final correct answer. So by using this, I have not calculated by using this formulation. Remember this. I have not used this formulation to get the value of transmissibility ratio. I have only applied the concept of the graphical approach of the transmissibility ratio. Is this clear? Understood? A very easy question, but the question is very interesting. Okay, so slight we can say smart work will be able to answer to these kind of questions very easily. Only thing you have to do is you need to understand how we are, and I hope so you know how we are getting this curve of transmissibility ratio between omega by omega n. Okay, fine, very good. The last question, the fifth question on the screen. Consider the system shown in the figure below. The rope goes over the pulley and a mass M is hanging from the rope. A spring stiffness key is attached at one end of the rope. Assume the rope is inextensible and there is no slip between the pulley and the rope. The pulley radius is R and the mass moment of inertia of, now they are directly given the pulley mass moment of inertia, that is J. What will be the natural frequency of the system? Okay, what will be the natural frequency of the system? It is something like this. This is your mass M. And there is a pulley which is hinged at this point. It is having J as the moment of inertia, right? This is having the J as the moment of inertia. So it is very easy. If I say there is a deflection, there is an X deflection in the mass M. So here we'll be having a theta deflection over here, right? So can I say, and here we'll be having X. Can we say X is equal to R into theta? X is equal to R into theta. Whatever deflection will be happening in this particular mass X, so same will be having this. So this will be equal to R theta. So X is equal to R theta. Okay, so over here the spring stiffness will be having r square. So here we'll be using the concept of energy method because it will be very easy to solve. So what is the kinetic energy? The total kinetic energy of the system, that is equal to half into m into v square plus half into j into theta dot square. Okay, what is velocity? This is r theta. So we can say velocity will be equal to r theta dot. So this is half into m into r theta dot whole square plus half into j into theta dot square, right? Okay, so this is kinetic energy. What is potential energy? That is half into k into x square. What is the deflection in the spring? That is x. Instead of x, we'll be writing in terms of theta. That is equal to half into k into r into theta ka whole square. Kinetic done, potential done. Now we can calculate the value of total energy, that is the summation of kinetic plus potential, right? Okay, so this is half into m into r theta dot whole square plus half into j into theta dot square plus half into k into r theta ka whole square. Now we know that in the energy method, what we are basically doing is we are applying the simple conservation of energy, that is the total energy will always remains constant. If I try to differentiate this total energy with respect to time, it should be equal to 0. So differentiating this, so it will be half into m into r square. This will be 2 theta dot into theta double dot plus half into j into 2 theta dot into theta double dot plus half into k into r square, that will be 2 theta into theta dot equal to 0. So theta dot will be cancelling out from each and every term, 2 will be cancelled out from each and every term. So we are left out with m r square theta double dot plus j into theta double dot plus plus k into r square theta equal to 0. Okay, or I can say m r square plus j into theta double dot plus k r square theta equal to 0. So rearranging this equation, that is equal to k r square upon m r square plus j into theta. Okay, comparing this with the standard formulation, theta double dot plus omega n square theta equal to 0. So natural frequency of vibration is k r square divided by m r square plus j, or omega n is equal to root of k r square divided by m r square plus j. This is the natural frequency of vibration of this system. So the correct answer is option D. Okay, the correct answer is option D. Right, now it's very easy. Many number of times they won't be giving you the moment of inertia. Okay, many number of times they won't be giving the moment of inertia, right? They'll be giving you mass and radius. So instead of j, we can, let's say this is a disk, we can say it as m r square by 2. If they are giving, let us suppose if they're giving the mass and radius, then it will be having m r square by 2. Let's say that is capital M. Okay, let's say this is capital M, this is radius r. So m r square by 2 will be the moment of inertia about the center, right? So majority number of times they'll be giving you the mass and radius. In this problem, they have given you the direct mass moment of inertia. So no need to have any problems. We can directly get the value. And from this, we are able to cover almost every single segment from the vibration. So as we know that this Sunday, we are coming up with the very important panel discussion of ESC. Means you know that ESC ka paper this Sunday hai. So what is the level of paper? What should be the safe score, and what will be expected, and what should be your strategy for 2024 ESC, right? So this is an helpful session for all the aspirants, those who are planning to give engineering service in 2024, and also the student those who are already given this paper will be having some live discussion with entire panel live in front of you. This will be on Sunday, only on your BYJU'S exam prep, GATE, mechanical and civil channel, right? So thank you guys for joining with me. I'll be sharing this PDF on my Telegram channel. You can download from there. And for free e-resources. There is a link in the description. You can click on that and you can download the resources. And the scholarship test that we have already mentioned, the link is already there in the description, right? So this is it from my side. I hope you all enjoyed 5 very important questions from the topic of vibration. Next week we'll be taking some different topic, different questions, but ultimate goal is you should be knowing what is the concept behind solving the question. That's it. Okay, thank you guys, take care of yourself. We'll meet tomorrow with more such session, and this Sunday again, I'm repeating, we'll be coming up live with the entire panel. Thank you everyone. Prem, Arnab, Raja, everyone who has joined the session, thank you, and stay connected with your own BYJU'S exam prep. Thank you guys. Bye bye. Take care.